Good afternoon, everyone. Hope you are able to hear me. Can I get a quick confirmation? Okay, thanks for confirmation.
So we'll be starting in another 2 to 3 minutes. Let's wait for others to join. Okay, so we'll get started. So thanks for joining this webinar. So today is the last day of this particular webinar series, and today we will be discussing about recurrent neural network and then just the stock price prediction using the recurrent neural network. I won't go much deeper into the mathematics of it. So a lot of mathematics formula is there, but I want to give you the overall picture of this. So just to recall, so far, whatever the things we have done. So we started with neural network. So in the first session, we started with the neural network. And as I told you, we would be simulating the way the biological neurons, so the neurons, as the biological neurons works together to solve a particular problem in the same way. So we are using this neural network to solve the kind of the problem with reference to the artificial intelligence. Then we had a discussion about the neural network and then different kinds of neural network, CNN, ANN, and then today we are going to use the RNN. So ANN, as we have discussed, the problem with ANN could be used for simple kind of a classification or prediction kind of a thing. But when it comes to processing complex images and all, then it is good to go with the CNN, that is a convolution neural network. Convolution neural network is good for like image classification. So anything to do with the image classification and all, it is good. But when it comes to the RNN, so the problem with the CNN here is like it won't have any memory, in the sense like the whatever the data points we are taking and we are training, so it won't have any relationship with the previous data or the any other data. So it works like quite independently. But in some of the scenarios, we want to get the context in which we are working. So those scenarios are like, for example, what is called as in the natural language processing. So in the NLP, natural language processing. So basically, here, if I just use the machine learning, so if I want to frame a sentence statement, and after that, like in Gmail and all, it what you can call it as autocomplete. So there is a facility of autocomplete, right? When the moment you start typing something, it prompts you. So when it prompts you, so it has to know like what are the previous words and what is the context, what is the subject on which you try to write this thing. So in those scenarios, we will be using the recurrent neural network. So NLP, natural language processing, and then the translation, like whatever Google uses, translation, and all these virtual assistants like Amazon Alexa or Google Assist or Cortana and all. So they typically uses this RNN, and also the time series analysis. When we have a time series data, so time series data, like for example, the stock and trade, right? So the any stock information. Suppose I want to predict, or I want to predict like what is the future. So next week is that stock is going to go up or down or anything. It is based on the previous data, right? So it cannot like work independently the way the ANN or RNN works. So in those scenarios, we are going to use the RNN, the recurrent neural network. So where there is a bit of like memory involved in this, in the sense it knows the context, and also it knows like previously what has happened. So from that perspective, we wanted to use, then we will be using what is called as the recurrent neural network. So let us, with that bit introduction, let us see what is that we will be doing today's class session. It is introduction to the recurrent neural network and the stock price prediction using RNN. So here we will be using using two things when we say stock price prediction. One, we are using web scraping. Another one is we are using a third-party API to get the what you can call it as the prices of the stock of the what you can call it as Nifty top 50. So top 50 shares prices we are going to take, and we try to analyze that and then try to the predict the values of that. So that is what pretty much we will be doing in the today's session. Okay, hope you are able to hear now. I think everything is fine. Yeah. So now going ahead. So recurrent neural network, if you want to go with the definition or something, is generalization of the feed-forward neural network that has an internal memory. It is a network with the internal memory. RNN is recurrent in nature as it performs the same function for every input of the data, while the output of the current input depends on the past one of the computation. So as I told you, the case of predicting the price of a stock. So again, it depends on the previous closing, and there are many such things are required, right? The past performance is required. So it has a internal memory to do that thing. So after producing the output, it is copied and sent back to the recurrent network. So for making the decision, it considers the current input and the output that is learned from the previous input. So that is what. So we have to know like the what is the output from the previous action. That is what is required. That is where the internal memory is used. So far, whatever we have used like CNN or we call feed forward neural network in the sense where in those cases we are not dependent on the previous information, so it is quite independent. So here it is not so. It depends on the previous inputs and to take the decision. So in those cases, we are using the recurrent neural network. In that, one of the recurrent neural network or modified recurrent neural network, we call it as the LSTM. So the recurrent neural network has some kind of problem which we call it as the vanishing gradient and exploding gradient. So I won't go very deep into discussing those things. So when we use that CNN just like that, it sometimes the feed, what you can call it as the backward propagation. There is a forward propagation and the backward propagation. So that means, suppose say we have an image and we want to classify it. So it is like when we as we discussed in the previous sessions. So if the image is there, so the image we are going to bifurcate and we are going to get the feature, and each feature we are going to assign some weight and check whether the whatever the expected thing and the current whatever the predicted thing, is there any difference. If there is a difference, we call it as the difference we want to minimize that. Okay, so we want to minimize the difference. Then we are going to give the feedback when we go back, and then once we give the feedback, then the weights are adjusted, and then so that the loss function, we call it as a loss function. Suppose it is like predicting something, the actual value and the expected value. If the gap is too much high, then we try to adjust the weight and do that. So that is what we try to do. So here LSTM overcomes those kind of issues like vanishing gradient and exploding gradient, and that is most probably used. The one one variation of the RNN which we are using is the LSTM, that is called as the long short term memory. That network we are going to use typically, that is used for these kind of scenarios where we wanted to predict the price of a stock, or like natural language processing when we are using a chart bot kind of a thing. Okay, so that is what we are going to use. And applications that are built on RNN, as I told, like it is natural language processing, image captioning, Google Translator, and then auto sentence completion, right? Time series data analysis. So these are the few of the applications which are built on RNN. So image classification is good to go with the CNN, whereas RNN for this purpose. And if you compare like ANN, CNN, and RNN, so on few of the parameter, so the data, what kind of data we will be getting. In case of the what you can call it as the CNN, it is just the image data mostly we work with. RNN, that is what we are going to use. That is where we are going to use the sequential data. It is the time series data. It could be a text data or it could be audio data. So recurrent connections only in RNN, it is just parameter sharing RNN and CNNs. That means like if already we have some features and that could be shared when we are doing the next epoch. And spatial relationship, as I told you in the last session, suppose if I have an image, and if the face of an animal, it is the animal, and if the face is tilted here, still it is able to identify in case of the CNN. Okay, that is called spatial relationship. Vanishing and exploding gradient. So that is there with all the things. Yes. But when we see the CNN with LSTM, so that is where those things could be overcome. Okay, this is a small comparison between this. And there is a forward propagation and backward propagation. So that is what we do. In this case, there is only the additional things what we will be using in this neural network is the previous output of the previous thing previous, it is a time series data. It is a time series data. So this network neurons, or I mean, the network is built for different, what you can call it as the data which is in the time series, and the previously outcome of the previous analysis would be taken for the next iteration or the next time series. So that is what we do in the RNN, or the forward propagation. So that is only the additional things we are going to do. Same thing, like we are going to use find the loss function, and once we find the loss function, we try to reduce the loss function. So whenever it comes to either classification or regression or any kind of a problem, what exactly mathematically what computer is going to do here when it's a machine is learning, it basically we are going to apply some mathematics, and a machine can do faster in terms of the computation and all comparing to us. So that is what it does. In terms of finding the loss function, there is something called global minima. That means we wanted to see like the loss in terms of the expected value and the actual value. If it is minimum, then we can say, okay, we have reached our goal. Okay, so that is what we try to do in terms of the neural network, right? So that is what we try to do. So the forward and the backward propagation is where we try to recalculate the weight and try to see that the loss function is minimum. So that is what we try to do. And there are a lot of mathematics involved in this. I don't go much into the details of this. And we will be using functions like softmax, value, and all, so that we have discussed in the previous class. So now let us get into what is called as this particular use case. So with that, we can see like what exactly happens, what is the day-to-day work of any engineer who want to get into what is called as the machine learning or artificial intelligence. So here what we are trying to do is we are trying to predict the price of the stock. Okay, we are trying to predict the price of the stock. So there are a few things involved in this. The first thing is, where do we get this information? Okay, so where do we get this information? So what we are trying to do is, the first thing, we wanted to see the Nifty top 50. So this is the Indian, what you can call it as stock exchange. So there is a Nifty. We wanted to see the top 50 shares. We wanted to get the information about the top 50 shares, and we wanted to analyze those top 50 shares. So that is called as the Nifty. So if you go and then search in the net, and if you see the top 50 companies as far as the Nifty is concerned, so this is where the URL is there. You can get those things. So this is what we are going to do in this particular use cases. We wanted to predict the Nifty 50 stock prediction. That is whether you want to sell a stock, or whether you want to buy a stock based on analysis of the previous values, and then coming up with the prediction whether you want to buy or sell. So that is what we wanted to do. So the first thing is, we wanted to know now which is the top 50. How do we know what is the Nifty top 50? So this is, we are going to use the Wikipedia, Wiki's Nifty 50 page, and then from that we are going to do what is called as a web scraping. Web scraping is extracting some data from the net. Okay, so for that you have Python has library to extract the data from the net. Okay, that is what we will be using. So that is the first step. First step is we are trying to get what is the top Nifty 50. It may change, like every time it is so dynamic, so it may change. And second thing is, where do we get the stock price? Okay, there are different APIs. There are few APIs are available freely. We are going to use one thing called as Quandl, and the API. Using that, you can get the stock price. Okay, you can get the stock price on various past data. You can say you want to get the prices for last 7 years or whatever this thing you are going to do. And then we are going to do what is called as the pre-processing. So we are going to train the data, and we are going to see whether based on this, whether we will be having some kind of a calculation to see whether based on the Nifty value and the value of a particular stock, whether it is good to sell or good to buy. Okay, that is what we are going to do. So that we will be saying the pre-processing, and then once we do that thing, because it is a label data. So now whatever we are going to do is we are going to do the labeling and we are going to do the prediction later. So then we are going to build the model using the LSTM. That is the LSTM model we are going to use of the RNA, and then we are going to do it. So now first let us get with the first thing. The first thing is to get what is called as the, if you go to this Wikipedia and then Nifty 50, then see, this is the Nifty 50 is a benchmark of the Indian stock market index that represent the weighted average of 50 of the largest companies listed in the National Stock Exchange. Okay, NSE is the National Stock Exchange. So where it is going to get us the top 50 benchmark. Okay, so they are published. What are those top 50 companies? So what we are going to do is, if this page is given, I wanted to get the top 50 companies. Okay, so where do we get the top 50 companies? See here, Adani Ports, Asian Paints, Axis Bank, like that. So Cipla. So these are and I wanted to get their symbol. What is the symbol? This is the stock symbol. Okay, stock symbol. Suppose if you check the INFI. This is the Infosys. So INFI is the stock symbol. Similarly, ITC Limited, ITC, like that. So every company, when they list it in the NSE, they have a symbol for the stock. Okay, these are the top 50 as per the NSE, National Stock Exchange. So the first thing what we are trying to do is we wanted to extract this information, top 50. And second thing is, once we have done that, we are going to get the stock prices of using these symbols. Where do we going to do? So this is the first thing we are going to use. The second thing what we will be using is, this is the first thing we are going to use. Okay, so the second thing is, we are going to get the stock prices using the third party vendors. Like, so what are those third party vendors? It is called quandl.com. You can register and then you will get a key. Okay, where you can get the financial data. So this is from here you will get the financial data. So this is the another one. Okay, so the first one is to get the Nifty 50, and the second one is to get the if I get the stock symbol. Okay, so I have shared already. So I have already shared with API key. API key is you have to register. You have to register and you can get the API key. Okay, so you can register with quandl.com and then you can get the API key. So it is just a simple registration step, and then you will get the key, right? So this is what we have to do. Yeah, and also they had given how do you integrate with various programming languages. If you look at this, see with the Python, how do you integrate? So how do you call this? So they had given a documentation, and then see how do you get it. Say, suppose if I want to get the Fed GDP in the US, so then this is how you have to call this. .get Fed GDP, like this. So they will be giving us a documentation how to use it and all. Okay, so this is what each one of them gives us the information. Say NSE, suppose a NSE oil 1.1. Okay, so this is the NSE. This is how you have to get this thing. So this is the Apple. Suppose if I want to get the price for the Apple, this is how you will get. So they have given you how to use this, right? So the first thing is we have to extract this data. So in order to extract the first data is the Nifty 50, what we are going to do is we are going to basically extract this symbol. For that, we are going to use the web scraping. Web scraping is a technique where in which if I pass this URL, it is going to give a text. It is going to give the text. So text may be whatever the way you want to parse it, you can parse it either using the HTML parser or the XML parser. And then from that, you have to extract this. You have to extract this using the HTML tags. Using the HTML tags, you have to extract it. Okay, so for that, like you should know like how to get this particular HTML tag and do it. So for example, now, so there is a library called Beautiful Soup. There is a library called Beautiful Soup. We are using that library to extract this. So we are going to use the Beautiful Soup to extract this particular information. That is what we are going to do. Okay, so we have to import this library of the Beautiful Soup, and then rest. What is that? I'm using a parser called XML parser, and then it is going to give me the soup. When I run this, see, when I run this, I would be getting the document like this. It is like a view source. It is like a view source, right? Suppose if you go to the website, this one, and right click, okay, or you can use view source. Suppose a view page source, right? So if you say view page source, the way you get this source, right? So in this way, you will be getting this information, right? Which has table TDTR and all. So that is what we will be getting when we use this. So after that, we have to get to those that particular table where we have to extract the symbol of the NSE top 50, right? That is what we are going to do. So for that, we have to use like soup.find table, and then class is equal to wiki table, and then sortable, and then in that we wanted to extract the t body. So what happens is like when you go there and you have to just do no bit of HTML, CSS and all, because we wanted to extract this information. So when we want to extract this information, we have to basically see here, we are saying table classes wiki table, and it is sortable. So what I am trying to say is we have to go to this particular table. We have to search for this particular table in the text what we have extracted. From that we have to go to this table body, because I am interested in this data. From the table body, we have all this TR and all. So in that, I wanted to extract this. I want to extract this. So it is like Beautiful Soup is like where you have to go, identify that particular, we call it as a selector. So you go and then pick that particular location where you want to get the symbol. So that is what we are going to do here. So in this case, if you look here, so dot table, then we are printing the table. When you print the table, it would be like this. In that table, we are going to get the ticks. So in order to get the ticks, again we are going to use the Python list. So we are saying that find all TR. So once we go here, get all the TRs here, because in the TR only table row you have the data. In that TR, I have to get the second one, because the first is the image, second one is where I have the symbol. So we have to extract in that way. So in that, you ignore the first row, because first row is the header. Then after ignoring the first row, in that pick the text where we have this symbol, and then you have to split the dot, because dot is not useful here. See here we have like Adani ports.ns. So what is important is the Adani ports. So we are going to pick that. Okay, so that is what we are extracting. So once we extract that information, then we are putting that information into a list. Okay, we have done that into a list. So what are the first thing? First, we are going to put it into a list, and then we are going to save it into a pickle file. So we call it as a file. It is a specialized type of a file, usually used to store the binary information. So we are going to use the pickle file, and we are going to store it. So when I run this, it is going to create this file called nifty50 list pickle file. and in that file we have to do. And most of the time of the data science or data engineer goes into pre-processing, cleaning of the data. So a lot of time goes for cleaning the data. Like for example, to tell you one simple example, here in the Nifty, here Nifty top 50, the symbol of Bajaj Auto is Bajaj Auto, Bajaj under hyphen Auto. Whereas in the financial API where we wanted to extract, it is Bajaj underscore Auto. Okay, so we need to replace that. Otherwise, this stock price won't be extracted. For that, we will be using something called lambda function. So lambda function is anonymous function. So which would help us to do this kind of things. What we are going to do is we are going to get the list of all the stock. In that, what we are going to do, we are going to replace this Bajaj hyphen auto with Bajaj underscore. So this lot of time is spent on pre-processing. So that is where the once you get the data, the cleaning the data, cleansing the data, taking out the duplicate data, removing the null data, or if some of the data is missing data, handling the missing data. So those are the things goes into when we do this. Okay, so that is what typically we will be doing. So, and similarly, you can say M&M, Mahindra and Mahindra. So it is M&M here, but actually in the stock ticker, it is, I mean, in the financial API, it is MM, like that. And at the end, we are going to append the Nifty 50, Nifty underscore 50. So that is also Nifty underscore 50 means it is going to give you the value of the overall Nifty 50 closing and opening. Even though it is not a physical entity as such, it is going to give you the overall value of the Nifty 50, right? So this is what we are going to do in the first step. So that is the step one we are going to do. And when we want to scrape it, and if it is already there, we don't want to scrape it. We are going to pick it. So that is what we are going to do. So the first part of this entire thing is to extract the data. This is the first part, is to get the information about the symbol of the we call it as a ticker, right? We call it as a ticker from the wiki's page, wiki's Nifty 50, using web scraping technology, or web scraping API rather. So where we are going to get the information. This is the first part. The second part is, once we have this the ticker, I want to get the price of the stock over a period. So it all depends on what kind of analysis you want to make and how much historical data you are going to do. So for that, as I told you, this Quandl API, which helps us in pulling the data using the API, we are going to pull the data by passing one by one ticker, and also mentioning the date range, like from which period to which period I want to get this. Okay, so that is the second step we are going to do. So this is the first step, and then second set we are going to do. Okay, so let us go there. The next step. So in the next step, we will see like how do we extract this information. So once we are done with this, yeah, we stored this information into a pickle file. So if you look at the pickle file, it will be something like this. It is just like a file. So this is the pickle file with the extension, and if you open it, you cannot get anything in that. It is like an encrypted way. So it is this particular file with the extension pickle. So this is where you convert this data into this in this format and store it. The next thing is to how do we call this API? How do we use this API? For that, again, you have to, yeah, this is the one. So here I have get the stock data from the API, that is the Quandl. So here again, the method is, first we have to install all these things, APIs, pip install you have to do. You have to install this Quandl, and then it has a method called get. In the get method, you have to pass three parameters. One is the symbol of that the particular company. Like if it is an INFI, I have to pass INFI, and then the start date, from which date you want to pull the data, up to what date you want to pull the data. So it is going to give you the day-wise data. Okay, it is going to give you the day-wise data. And once I have that data, I'm going to save it into a CSV file. So comma separated file, I'm going to save it inside this folder, that is stock data, and then the ticker.csv. Ticker is the particular name, company's name only it is going to save. That means it is going to create a CSV file for each company. It is going to create a CSV file for each company. Okay, so that is what we are going to do. So when I call this function, suppose when I run this function, then it is going to create those things, and this is how it would look like. See there is a folder called stock data. Look here, all the top 50 companies stock price is there. So for the given period, what is the period I have given here? So I have given some old period only, just in order to compare that data. See, this is what I have given. Yeah, so we had given the date. I think initially only had declared the date between, yeah, this is the date, start date and end date, somewhere 2014 to 2020 April. That is what is given. We can give the as on date also. So from it is going to pick the data from this. So the data would be in this way. Suppose if I look at the INFI, if I open INFI, so this is what is the date. Date wise, we got the stock opening, high, low, and what is the last value, and then the close, and then the total traded quantity, and then the turnover. So on that day, how much trading has happened and what is the turnover in terms of the lakhs. Okay, so like this is the financial information. So we will be getting for each company. So each company we will be having a file like this. So this is what, with the help of the third party API, we can get this information, right? So in this we are interested in only few things, like maybe the closing and maybe high. Okay, so whatever the information is required, next step is to we have the information of all the companies, separate Excel sheet, and finally when we wanted to do the analysis, we wanted to put them in one sheet, and then we wanted to compare and do that. Okay, so for that purpose, again we are going to loop through this, pick some of the column, and then again create another sheet which is a consolidated sheet, so that we can do further analysis on this. So this is how a particular file would be. Okay, so after that, this is the API key. So in my case, this is the API key. You can just get the API keys, and by registering, and you can get the API key. And this is the day range, start date, and the end date. So this is the code to extract that information. Yeah. So once we have done, then you can just get check whether for one company you can pull, or you can pull for multiple companies. So now what we are going to do, as I said, like we are going to read the data. Now we are going to read the data, and we wanted to create one consolidated sheet, and we are taking only two values. One is the close value and the shares traded. Okay, the close value and the shares traded, only those information we are taking from every company, and then I am going to create another CSV file, and I am going to put it. Okay, so here, like for if it is ticker is Nifty 50, that is the consolidated one. Just I wanted to change the column name differently, so that's why I'm using this. So this is what we are going to use, and then we have extracted the two information. One is the close the column name is close, and then the columns would be like the ticker underscore close, if it is info underscore close, and the share traded. So this is what we are going to do. We are going to use the create another data frame. So here we are using pandas. So pandas is one of the library which is used to it is a tabular data. It is used to create a tabular data the way Excel is there. Okay, you can do a lot of the way you do query using SQL. Same thing you can do with the pandas also. So where you can do like any aggregation function, finding maximum, minimum, comparing, and all those things you can do. Okay, so we are concatenating this data, and then we are going to create a new file called as Nifty 50 closing prices. So what is this Nifty 50 closing prices? So we have got the individual data. From the individual data, we are creating a consolidated data of Nifty 50 closing prices. This is the second Excel we are going to do here. Okay, see, this is how we have created for each day. See, for each company. So now the data which was like row wise now became column wise. So it is what happened. So day 0 to we have data for so many so much data, right? We have got now extracted much data. It's almost okay, around 1163 rows we have. So for each of the day we have extracted this information, and at the end if you look at, there will be Nifty 50 volume, as well as it is Nifty 50 volume and Nifty 50 close, right? So all this information is there. So this is what we have done. So once it is done, again we'll go forward. Then yeah, so this is what we are going to do. We got this data. So this is our pre-process. Now pre-processing what? Now what I wanted to do, I want to group the data. Like suppose if I want to do the prediction, so now on how many days data you wanted to use to predict. So here I have taken the series length as 30. That means I want to reorganize the data such a way that the 30 days data I will take, and then I am going to predict use that data, and then the prediction period length. Prediction length means so based on that data, so I wanted to predict the prices for the 1 week time. Okay, so this is how much data I want to take, and then how long I want to predict. These are the two things. So we are parameterizing this. We call it as the series length and then the prediction length. Okay, and then what is the ticker you can use like Nifty 50 or anything. And second important thing is to normalize the data and scale the data. There are some of the operations we wanted to do. So we want to convert them into 0 and 1, because you have different values for each of the column. We want to bring it to a common scale, so that when we try to build the data, the variations in terms of the scaling won't be there. So that is what we are going to do. So these are all a lot of pre-processing we are going to do. So we want to get them into the same, what you can call it as the scale. Okay, so that is what we are going to do. So Nifty 50 close. So here what we are trying to do is we get this data. Say for example, some previous data of say day 1, like that. We wanted to prepare data like this. We want to make a chunk of data day 1, day 2, day 3, day 4 and all. So whatever this data is there, let me just, for example of demonstration, let me take 7, and then you have some value. And then we can use this, and then using this we wanted to predict the data for the next few days, like that. So this is the one side. Like that, we wanted to what you can call it as the segmentize the data, or whatever the data is that we wanted to slice it and put it, and then based on this we wanted to do the prediction of the eighth day. Already I have the data for the eighth, and then we will use this, and then we are going to see when I predict it whether I can compare whether the prediction is proper or not. Okay, so that is what we are going to do. So that is the next step we are going to do like this. So this is what Nifty future close price. This will contain the data of Nifty 50 close after 7 days. Okay, 7 days. After 7 days, we are going to create one is called as the Nifty future price, and then the Nifty flow close is the data from day 1 to day 7. Okay, or based on whatever the frequency you give. So we are going to prepare like a bucket like that. Prepare the because it is a time series data. So in this is the time series data. We have to prepare the time series data in that way. So that is what we are trying to prepare this. Okay. So this is a bit different from whatever we do in the regular ANN or anything. In this case, it is a time series data. Okay, so that means we have to generate the sequential data so that it's some dependency in the past data. We can see that what is the dependency of in order to predict the future. You have to look at the past data. So that is what basically we are going to do. We are going to create the based on the length, the prediction length, whether it is 30 days or 1 week or whatever it is. We are going to prepare the data in that way. So when we are preparing the data, we are going to check something. So if the Nifty future price is greater than the Nifty 50 close, then whether we are going to assign 1 or 0, it is equivalent to like selling or buying. Okay, so we are going to label this. So we are going to create a label, DF label. So based on that, for each of the data, we are going to label it. We are going to say whether you can based on some logic. Here the simple logic is like Nifty future price, whatever we are going to calculate. If it is greater than or equal to the close price, that is what. So in real scenario, maybe so recently one of the financial institutions approached me, and they have some kind of a logic, and they wanted to build this real streaming data of the stock price they wanted to take, and they wanted to build some logic so that they can actually suggest their customer whether when to buy or when to sell. Okay, again it depends on the what kind of logic or based on their intuition, but this would help us to do those kind of calculation. So here in this case, only simple thing we are doing like Nifty future price. If it is greater than the Nifty close, then it is 1, otherwise 0. So that is what we are going to do. We are going to create a new label. So that is what we are going to do. And then we are going to create this as Nifty 50 future label. Okay, this is the future data. Future data. We have taken that the period for that we have created the future label. So this is what we are going to do here. So if you look at this, future label is like this. For each of that particular period, these are the future label. So this is how the data would be. And if you look at the end, see the label is there. See here it is 0 or 1. So this is what is meaning of labeling the data. So based on this, whether we wanted to buy or sell or whatever it is we wanted to do. So based on this, we are going to do it is 0 or so what we are comparing at that particular time, like Nifty future price with the Nifty close price, and then we are going to label the data. So once we have labeled the data, now we are ready to train this using our model. Okay, so these are the few things we have to do pre-processing. This is what we are going to do. And then we will be doing some of the buying or selling. Okay, and then basically that is what is the output of this. So once we have this output, the next thing we are going to go about is to build the, so this is what is the final DF it comes. And now we are going to build our model. So up to this, we have not used any model building or anything, just pre-processing and then getting the data and then getting the future data. Just we are going to, we have organized the data and then we did some kind of a comparison. So now we use our model and then see the model, how it is, how good it is about predicting this thing. So if we will use sell is equal to 0, buy is equal to 1. If the Nifty future price is greater than the close price, then I think here buy, then it is buy, otherwise sell. Okay, so then we are going to do the build model building. Again, here we are going to use this RNN, okay, recurrent neural network. In that, we are going to build this model. Yeah, first we have to train and test the data. We are going to split the data into training and testing. So around 80% we have taken for training and then 20% for the testing. And then we are going to build this data. And then we are going to use the building model, sequential, adding these libraries, LSTM, and then we are going to pass the data here, and then we are going to use different layers like LSTM, batch normalization, and then we are having 2 and then the third. So it is like stack. We are going to stack various things, and then finally the output, we are going to use the activation function as the sigmoid. Okay, so that it is quite, and also in some of the layer we are going to use the activation of the value. And finally we are going to build our model, and then we are going to check the accuracy of the model. So the model, whatever we have built, and what is the accuracy. And then again we are going to run it for so many iterations. We call it as epoch, and I used 5, and you can look at the accuracy. So as the model gets trained, the accuracy is going to improve, the loss is going to reduce. Okay, so that is what we are going to do, and also we can predict the like how it is going. So the green label is the predicted data, and then this is what is the actual data. So actual data is in blue, and then the predicted is like this. So that is what we can compare, and then we can see like how this model is really helpful in terms of doing this thing. Okay, so this is how we can do this stock price analysis. So even this is just to give you an insight into how we can use the neural networks to solve a kind of a problem, maybe it image classification or predicting the stock price. Okay, so with that, I think we have come to the end of this 3 days session, and as you know, myself Raghu Prasad, and if you want to further, we are offering these courses, and it's Python with deep learning is 60 hours course, and the course fee is 15,000, but for the people with those who are attending the webinar, we have discounted price of around 13,500. So if you want to register for this course, you can contact me. I will just put my contact details here. Yeah, if only few companies, you can prepare a list of those companies instead of the other companies. You can only select, have a list, and then with that list you can see. Basically, what we are doing, instead of having top 50, in that you can have a selection. So you can have the list of the companies which you want to use. So yeah, recording will be shared. If you want the PPT, you have to write a mail to this mail ID separately. If you want the PPT, I have shared my mail ID. If you want the PPT further, you can this thing. So your recording would be shared, and also it will be put onto Skill Upright website. And if you want further interaction, you can contact me, Raghu Prasad Konandur at kaushalya.tech. And also I have put my number. It is 9845547471. Okay, so hope this was useful for you. Yeah, data set and notepads, we are not going to give you, in the sense, if you separately send me a mail, send us a mail, then we will do that. But in general, we are not going to do. But anyways, the recorded videos, that would be put it into the website, or you will get it in your mail. Okay, so Skill Upright, we have the YouTube video. Also, it would be shared in our Facebook page or in the LinkedIn. Okay, so that is where you can watch and you can get it. And yeah. Okay, so that's it for this session. Hope this was useful, at least to get to some kind of a understanding of the deep neural network and how do we use it, how do we get started with this. This is just a tip of the iceberg. And once if you are interested, please do contact us. We are ready to take this as a course, and so that you can go deep into this. Okay, so thank you very much, and that's it. And see you soon with some other set of webinars. So in the coming months. So all the best for your future. And that's it from my end. Myself, Raghu Prasad, signing off, and see you soon in the near future. Okay, bye bye. Take care. Okay, thank you. Thank you, Lina. Thank you, Aprajita. Thanks, Krishna, Vijay, Diksha.